First of all, good morning all. Hope everyone is doing great. So today our topic is on the system design. So we'll take one of the example, like we'll try to design a micro blogging site, just like a Twitter, right? So we'll take that as an example and see how we can start designing the application and what are the concepts we need to consider in order to design a Twitter-like and system, right? So before that, yeah, myself, I'm Sharath. I am like an engineering manager in one of the tech organization, right? So I have overall close to 16 plus years of experience in the IT field. So I worked in multiple roles. So I worked as a developer, I worked as a lead solution architect and engineering manager, right? So not sure if folks have joined my previous session. So in my previous session, I kind of covered on the software architectural fundamentals, right? So maybe we will be leveraging some of the topics we have discussed or some of the concepts we have discussed in my previous session while designing the system like Twitter, right? Have anyone have joined my previous session? The participants, or everyone is new to this session? Okay, so most of them looks like few. Okay, first time here. Okay, fine. Okay, so since we have most of the first timers, right? So maybe I'll recap certain fundamentals which we have discussed in my previous session, right? So let me quickly share my screen. Hope you're able to see my screen, right? So this is our today's agenda. So this is our today's agenda, right? So the topic is software architecture with an example. Like we'll talk about certain example like about Twitter, right? So a quick introduction about myself as I discussed. So yeah, so this is me. And the agenda is like we'll recap the previous session, which is the software architectural fundamentals. Maybe we'll spend like 15-20 minutes to recap on certain fundamentals, which is essential for building a software architecture, which is essential for system design, right? And also we'll talk about certain step-by-step guidelines on how we can design a system, right? And we'll spend like enough like 1 hour or so on the designing the Twitter like an system, right? If time permits, we can take another design activity. If not, we can talk about Q&A and any other open items. Okay, so this is the agenda, right? Yeah, so before we start, any questions? Hope I'm audible and my voice is clear. Okay, so I am using a single monitor, so I may not able to kind of check the chat details, but feel free to unmute yourself and stop me if you have any questions. Okay, cool. Okay, so yeah, so we'll start with our agenda. So we'll recap on what we have discussed in our previous session, right? I know most of the folks are very new to this session, right? So in my previous topic, we talked about certain basic fundamentals. What is a software architecture, right? What is the fundamentals of a software architecture, right? So which is very important when you are working as an architect or when you're kind of designing any application, right? And also we talked about the expectations of an architect or a system designer, what has been expected out of an architect, right? So that's also something we have designed in our previous session. And also we talked about various architectural styles, right? So like we talked about what is microservice architecture, what is service-oriented architecture, what is layered architecture, and all those things, right? So basically, both we covered on the monolithic aspects as well as the distributed aspects, right? So this is what predominantly we have covered in our previous session, right? But as mentioned, again, we'll spend another 15-10 minutes, right, to talk about these concepts, or to refresh these concepts again. Okay, right. Okay, so what is software architecture is all about, right? So software architecture is all about four aspects, right? One is the software or the architectural characteristics. What is the characteristics of an application, right? So when I say characteristics, so these are, in some organizations we call this as a non-functional characteristics or non-functional requirements, right? So example, someone puts a problem statement, hey, I want to design a payment application, right? Oh, so looks good, right? Payment application, okay, we need to transfer money and all that things. So functionally we are clear. But there are a lot of non-functional aspects which are involved in this one-line statement payment application. What is the non-functional requirements? Example, security. You're dealing with the payments, so you need to ensure your architecture is taking care of security, right? You're dealing with the payments. Your application should be available 24/7 so that it can process the payments 24/7. So availability is one more non-functional requirement which we can uh, derive from that one-line requirement statement, right? And also scalability, right? So they might say that, hey, this is the payment application, right? Today it is being used by 1,000 people. Tomorrow it can be used by 10,000 people, then 1 million, 1 billion, so and so, right? Which means that we need to design an application which is scalable, right? So basically, the characteristics, the architectural characteristics is nothing but the non-functional requirements. Okay, so you have identified the functional requirements, or someone of your business team has given you functional requirements. Based on the business requirements, you are identifying the non-functional requirements like scalability, availability, reliability, uh, next serviceability, right? Auditability, all those things you need to identify, right? If you remember, I'm talking about, or if you see, observe, right? I'm talking about LETs, serviceability, maintainability, availability, scalability, reliability. Everything ends with an LET. So sometimes these characteristics is also called LETs, non-functional requirements, right? So as a designer, as a software architect or a software system designer, you need to identify the non-functional requirements or the characteristics for a given problem statement, right? So that's something we call it as an architectural characteristics, right? What is the characteristics of an architecture? Okay, so the first point is that the first important aspect is software in the software architecture is architectural characteristics, right? So now you have a functional requirements. Now you have identified the non-functional requirements, right? And you might have certain design principles and decisions. Example, your organization might say that, hey, always implement functionality using RESTful web services, right? Or using APIs, right? Always follow these standards, right? So there are certain principles and guidelines which are being emphasized within your organization, are certain best standards which is being used in the industry, right? Are best standards which you have defined for your team, right? So those are various principles and decisions. Okay, right? So now you have you have a requirement, you have non-functional requirements, right? And you have certain principles and design. So now combining all this, you need to identify what is the architectural style which suits your business need. Whether you need to implement using microservices or layer-based architecture or service-oriented architecture is something you need to identify. So that's called architectural style. So if you see on this figure, on this uh, the figure here, so this is what the architecture, software architecture is all about, right? So on the left hand side, you have an architectural decisions. The decisions are, okay, always encrypt certain data, right? That's one decision, right? Or the decision is always use APIs, for any communication between any components. That is the decision which has been made, right? Other is like design principles. These are principles. Hey, always follow these principles or these guidelines. The guidelines are, hey, the service layer only can call the database layer, right? So those are kind of a design principles which might be defined in your organization, or by defined by you, or defined by within your team. Okay. So the left hand side is the decisions, right hand side is the principles, and then you have identified the non-functional requirements or the architectural characteristics. So that is one aspect, right? Now, based on the design principles, based on the decisions and the characteristics, you need to identify the structure, which is nothing but what is your base. How are you creating your system? Whether you should use microservices, right? Or a monolithic, considering the cost and other aspects, a monolithic application or a space-based application, right? Or a plug-and-play application, right? So these are the various architectural styles which you can decide. Okay, fine. I'm making sense so far. Stop me if you have any questions. So we have discussed this at a stretch in my last session. I hope the recording might be available, so you can reach out to your Learning Bay partners to understand more about this as well. Okay, right. And also I do have a presentation which we have used in my last session. Maybe this has been shared, but yeah, I can reshare this presentation again as well, right? So this is what we have talked about. So the architecture, right? And also, yeah, what is the characteristics, the software characteristics, right? So like various characteristics which we talked about, accessibility, availability, archivability, and all those things, those are being mentioned over here. Okay, right. Okay, so what is an expectations of an architect, right? This is also which has been discussed in my previous session. What your organization, what your management, what your team is expecting from a system designer or from an architect, right? So one of the, we have basically core 8 expectations. One is make architectural decisions. You need to make a decisions, right? You need to make, hey, we will be going with this architectural style or architectural pattern, right? We will be using so and so standards, right? So those are the things as an architect you need to make. Okay. Another expectation is you need to continuously analyze the architecture. So let's say on the day one, you have proposed an architecture, it has been productionized, everything looks okay. And then suddenly you are seeing some anomalies in your production, right? You need to analyze that and you need to correct your architecture to support the new trends or new observations, what you have seen, right? So this is also something, an expectation from an architect. You need to continuously analyze what is happening. You need to look, you might need to work with your support team or your developers to see what are the challenges we are seeing, how you can address those challenges. This is also you need to take care, right? It's not like, okay, I have designed my architecture and it has been provided, it has been implemented. It's not like that, right? You need to continuously analyze, right? Keep with the current trends, the latest trends, like what is happening, what are the new developments, right? That is also an expectation from an architect, right? Your business team or your management might reach out to you to understand how we can leverage this technology or how we can improve the productivity or how we can generate more revenue, right? So that's the reason as an architect, you need to keep up with the current and latest trends. Okay. Ensure compliance with your decision. You might make some decisions. Example, let's say you consider that always you need to interact or integrate via APIs, right? You need to ensure those decision is being followed within your organization, right? Because sometimes you are working in a large scale application, there will be a lot of developers, right? A lot of engineers will be involved. You need to ensure the whatever the decisions which is being made are being followed, right? So this is also as an architect, this is also one of the expectation from your management, right? So diverse exposure and experience, right? You need to have understanding about various tools, various technologies, various trends which is happening, right? So I think this is what we talked about, right? As an architect, you need to have a technical breadth, right? Right, you need to understand, you need to know something about everything, right? rather than technical depth, right? You may not require to know, understand in detail on how Node.js will work, but you need to know when to use Node.js, right? And what are the advantages and all those things, right? So that's what I mean by technical breadth, right? What are the advantages of Node.js, right? When to use it? What are the disadvantages of Node.js? When to avoid that, right? Not required to know and see, hey, how to debug a particular, what you call, a particular defect or a particular corner case, how to debug that, right? That is not required. Or how internally the memory is being stored within the Node.js, right? You may not require to know all those details as an architect, right? So as an architect, is the expectation is you need to increase your technical breadth than your technical depth. Okay. And of course, as an architect, the expectation is you need to have a high domain knowledge, right? You need to understand what is the concepts of a particular domain. Let's say you're working on a banking industry, you want to know, understand at a high level, what are the regulations you have, what are the rules the banking industry will be adhering to. All those things you need to understand, right? And of course, communication skills is important. You came up with a better architecture, but that need to be communicated and that need to be socialized to your stakeholders. Then only it is more meaningful. If you're not able to do that, it's in vain, right? And also, yeah, important aspect as an architect, understand and navigate navigate the politics, right? You come up with a design, right? You come up with a proposal, so no one will uh, approve your design in a first attempt, right? Every architecture will have a trade-offs, right? You need to navigate, you need to explain. Everyone will say that, hey, this is not right, this is bad, this will not suit it, right? But you need to understand the rationale, you need to explain, you need to understand, you need to explain to a lot of stakeholders, right? There are technical stakeholders, there are business stakeholders, right? There are marketing guys, all those people will be there. So you need to, based on the audience, you need to kind of explain your architecture, and you need to talk to the right person so that things will be moving, right? So this is also one of the important expectation as a software architect. Okay, right? So I think this is what we kind of covered in our last session. And also the last session, we talked about various architectural styles. Like we talked about each and every architectural style, like what is a laid based architecture, when to use it, right? All those things we have covered, right? Maybe I'll not repeat it again, but yeah, maybe since microservice is an important architectural style which is being significant in today's market, maybe this is, maybe I'll spend 1 minute on this, right? So microservice is one more recent architecture which is like more popular in these days, right? But provided with the cloud evaluation and all, people started thinking about microservices architecture, right? So what is the advantages of a microservice architecture? As you see on the right hand side, so we have the characteristics rating, right? If you see here, one of the important high microservice is rated high because of the scalability, right? You can scale your application easily by adopting the microservice architecture, but you have some cons. It is costly. You need to spend a lot of money and a lot of resources in order to implement something in the microservice architecture. Okay, right? So what we have done in the last discussion or last session was we talked about each and every architecture. We talked about what is the advantages of each and every architecture and when you need to use the respect to architectural style. Okay, I'll stop here to see if there are any questions. Hope you are following up with me, right? If you have any questions, please let me know. Cool. Okay, fine. I think maybe we can start on the actual topic, which is like designing for Twitter, right? Or a microblogging site, right? But before that, like let's understand step by step concepts which is required for a system design, right? So step one, you will get a business requirement. Someone from your management will say that, hey, we need so-and-so product, right? As a software engineer or as a as an engineering team, you'll get a requirement, right? Step one, you will need to kind of study that business requirement, understand more about the business, right? And if you have any questions or clarifications, you need to make sure those are being addressed, right? Step one is all about requirement clarifications, right? You need to talk to your stakeholders, you need to talk to your product team, you need to talk to your marketing team, your management, and all that to understand more about the product. Why are we creating this product, right? What is our business rationale, right? What is our long-term strategy with this product? As an architect, as a designer, as a software engineer, it is important for you to get some clarification. It's important to clarify the requirements. That's a step. After that, estimation. When I say estimation, it is estimating, okay, the size, okay, how many users we are supporting, right? How large is my system, okay? What is the capacity, right? What is my storage? How much of database storage I need to procure so that I can support this product, right? What is my bandwidth estimates? Okay, if example Twitter like application, like a lot of people are using it, right? So what bandwidth I need to have? How much of investment I need to do for the bandwidth? When I say bandwidth, hope you're able to see my screen as well on the Zoom. Can someone acknowledge?
Yes, sure.
Okay, good, right? So this is what we need to do, right? We need to identify the non-functional requirements based on the requirements which has been outlined. So when you talk to your business, they might say that, hey, we are expecting a lot of users, right? We expect like maybe 1 billion users, similar to Twitter, right? Okay. And they might say that this is a global product, right? So we will uh, productionize this product across the globe, right? So these are the things which you learned after talking to your stakeholders, right? Okay, what does it mean to us, right? So, and also they'll say that this survey should be available always, right? 24/7, this should be available, right? So these are something when you're starting discussing with your stakeholders, these are something which you have identified. What is that? They say that our service should be highly available. That's what they might mention in the requirement document, or they might discuss this when you're talking to your stakeholders. Acceptable latency is 200 milliseconds for timeline generation, right? You know, right? In the Twitter, you have that timeline generation. You will see all the tweets which has been tweeted by your friends or your followers and all that, right? So what the business says that, hey, within 200 milliseconds, you need to populate that timeline. Okay, that's what they will say, right? And when you say availability 24/7, it is available, which means that, let's say there is an earthquake in one of the data center, still our service should be up and running, right? Which means that, let's say your data center is in US and India, right? If there is an earthquake in US, the entire traffic should be fail over to India data center, right? So that is what technically they mean, right? So which is nothing but the consistency. Consistency should be there, right? So in the interest of availability, we are providing that consistency, meaning routing the traffic from US data center to India data centers, right? During that routing, there might be a small delay, which we are saying that it's okay. It's okay to have a small slight delay during the failover from US to India data centers. Okay, right? So this is what you learned when you're discussing with your stakeholders, which is nothing but the product team. Okay. What we have identified so far, we have identified a characteristics called availability. We have identified a characteristics called performance, right? We need to be highly performed. We need to build a highly performed application, right? And also it should be consistent, right? Okay. Now let's perform, let's do certain capacity and planning, performance planning. Okay. As an architect, you need to work with all your stakeholders. Your stakeholders could be your network team or a cloud storage team, right? Or an operations team. You need to tell them, hey, how much of uh, storage capacity you need, right? You need to tell them how much of a network bandwidth you need, right? Hey, my tweet Twitter is kind of a highly high throughput kind of an application, right? I need more bandwidth. I need at least so and so bandwidth, right? The internet bandwidth, right? So that I can process that request properly. So as an architect, you need to do that capacity planning as well. Okay, so let's think about, like, let's, as an architect, how do you do the capacity and performance analysis, right? So based on your business, you are making certain assumptions, right? So your assumption is, okay, our business will provide you some assumptions. So there, let's assume we'll have 1 billion total users, right? So there are 1 billion users who is using our Twitter platform. Okay, with 200 million active users, right? Out of that 1 billion users, only 200 million are active users. Okay, so this is one assumption you made. What you have identified? You have identified the number of users, right? Assume 100 million new tweets every day, and average each user follows 200 people, right? So these are the assumptions, these are the metrics which has been given to you. You need to ask as well, as an architect, you need to ask your business for these details. Then only you can plan your capacity, right? So basically what we are doing here, we're identifying the peak and average load on our application, so that we can plan bandwidth, storage for our application, right? So these are the questions we're asking, right? How many tweets we will be having it, and maybe your business says that, maybe based on their analysis they will say that, hey, we might have 1 million new tweets, right? Okay, and each user might be having at least 5 followers, right? This is what your business might have provided, right? So based on these assumptions, based on these guesstimates, right, you need to plan your capacity. When I say capacity, it is all on storage, all on bandwidth, right? So that you can create a seamless, or create a good application. Okay, and you might, these are the questions you're asking, right? So how many favorites per day, right? We have a requirement, right? You have a business requirement saying that uh, user can mark a particular tweet as a favorite, right? So now your question is, hey, how many in a given day, how many favorites they will be, how many tweets can be marked as a favorite, right? You need to have some kind of an estimate, right? So we have an active customers as 200 million. Each customer or each user can mark max of or average of 5 tweets as a favorite, right? Which means that it is 1 million favorites. If you see the calculation, this is what the favorite, meaning on a given day, there will be 1 billion tweets which are marked as favorite. Okay, right? Fine. So next question we are asking is, how many total tweet views will the system generate? All right, how many times or how many times the user have viewed the tweets? All these things we need to do, right? Maybe in the interest of time, maybe I'll quickly go over saying that, okay, what we are having is, what we have identified is, we have done the calculation, it is like 28 billion tweets per day, right? There will be a 28 billion tweets which will be tweeted on a given day, right? Okay, so now we need to think about storage. Let's say each tweet takes at least 140 characteristics, 140 characters, right? How much of bytes we need, right? And some tweets will have images and videos, right? After doing all the calculations, we came up with some kind of a memory, which is like 24 terabytes of memory is required on a given day to store all the images, tweets, and videos, right? So these are the storage estimates we came. Okay, right? So now bandwidth estimates. So now what we are doing, we are to and fro, there will be like to and fro, when I say from server to client, there will be around 24 terabytes of data is being exchanged per day, which means that per second, I need at least 290 MB of capability of a data transfer, right? So this is the bandwidth estimates we have done. Okay, so far what we have done, we are doing the capacity analysis. Basically, as a part of our identifying the non-functional requirements, we are trying to do the capacity and the performance analysis. Okay, right? So far, any questions? Okay, so what does it mean, right? So in short, we need to provide a highly scalable application, right? By performing the capacity and performance analysis, what we identified is our application should be scalable. We have 1 billion users, right? But only 200 are active. But there could be a day, right, where all the 1 billion users are active. So our application should be scalable, right? So that's something we have identified. A non-functional requirement which we have identified is a scalability. Yeah. Okay, right? Fine. Okay, so now let's go ahead. Let's start doing our analysis, right? For further analysis, right? Okay, so what are the non-functional requirements we have identified? The non-functional requirements we have identified is scalability, right? Availability, right? Performance, right? And security, right? So the tweet should be secure and all that, right? And also consistency, right? And also auditability, like which tweet, who is the owner of this tweet, who has created this tweet, right? All those things need to be taken care of. Okay, fine. So for good, right? So I'm thinking about scalability now, right? So let's say scalability is one of the important non-functional characteristics which we have identified. So I'll go to my cheat sheet, right, to see which architectural style suits well, right? So what are the architectural styles we have? The prominent architectural styles. These are the various architectural styles we have. Let me check which architecture supports the scalability high. So here scalability is low. This architecture will not work. Scalability is low. I'll not go with the layer-based architecture. Let me go to the pipeline architecture. Here also scalability is low. I'll not go with the scalability architecture. Microkernel scalability is low. I'll not go with this architecture. Service-based, maybe it is okay, reasonable. Maybe service-based architecture works for me, right? But let's see. Event-driven scalability is good. Okay, great, right? But what is it's not simple, it is a little complex, right? So maybe I'll not go with that. It's adding a lot of complexity to my application, right? Space based, again, it is not simple, it is little hard to maintain, so I'll not go with this, right? Maybe service oriented architecture scalability is okay, not so great, right? Maybe I'll check with others, right? Microservice architecture, of course, yeah, this is also providing the scalability very high, but it is also not simple and it is also not cost effective. But this is the trend, right? I think I have enough capability, I have enough requirement to go with this. One of the reason is elasticity as well. If you see, my requirement is also elasticity. I think we did not mention that. Elasticity is also one of my important requirement. What is elasticity? We have in our system, we have 1 billion customers, correct? So in our Twitter application, the capacity what we have identified, we have 1 billion customers, but active are 200 million. But there is a possibility on a given day, all the 1 billion customers can access. It's like elastic band, right? You're contracting and you're expanding, right? On a given day, I should be having 200 million customers. On a given day, I can have 1 billion customers who are accessing the application, right? Elasticity is also one more non-functional requirement which I have. So considering this elasticity and scalability and my design principles and decisions, my design principle and decision is, hey, go with APIs only, right? So considering this, I'm going with the microservice architectural style. Okay, so what I have identified so far, I have identified my architectural style, which is microservice architectural style. Okay, I'll stop here to see if there are any questions.
Can you share the tables? I think we don't have the tables at least. So how to decide which?
Yeah, this is my last session, right? But yeah, definitely I'll share this presentation with you guys.
Thank you so much.
Okay. Fine. So what we have identified now, we have identified the microservice architectural style might suit this particular requirement, right? So two steps has been done. We have identified the NFRs, non-functional requirements.
Sorry, I have one
They-
question. Sorry,
Sure.
sorry. So why can't be it's like event driven? Uh, because Twitter is also mostly around some events. Here, event can be a tweet of another user, right?
Yeah. See, each and every architecture, it has its own trade-offs. Of course, to your
Okay.
point, event-driven also will work, right? There is no hard and fast rule to say that always you need to use microservices only, right? So this can be implemented using the event-driven as well, right? But why I have, if you look at this diagram, so event-driven elasticity is only 3 points. Whereas if I go to the microservice architecture, the elasticity is more. Elasticity has been well supported in microservice architecture, right?
Yeah.
Because of that, I have gone with this, right? And it's also costly, but my business is saying that, hey, I'm okay to fund you, right? And so that's the reason I have chosen this approach.
Yeah.
Okay.
I'm just thinking that why do I need elasticity over here, right? I mean, it's not like any, let's say, commercial e-commerce site where during festivals it will increase and other time it will be empty or little less load. Twitter is like
Mhm.
always bit consistent, more or less. So I'm just thinking aloud. Maybe I'm wrong, but yeah.
Yeah, your point is very valid, right? But why I was thinking elasticity is in my use case, right? If you see here, we have a 1 billion users, but active users on average
Okay.
is 200
Okay.
million,
Okay.
right?
So it can
But
scale up
let's
to 1
say
billion
there is
very
some
fast.
event, let's say some event, right? Let's say
Mhm.
PM Modi is coming to Twitter and he's talking about some program, right?
Uh-huh.
Maybe
Uh-huh.
on that day, there will be lot of events happening on Twitter,
Yeah.
right? So
Yeah.
that's where the elasticity come in picture for me.
Okay. Yeah.
Does it
Makes
make
sense.
sense?
Thanks. Yeah. Yeah. Thank you.
Cool. Fine. Right. So this is what we had. So what we have identified functional requirements, non-functional requirements. Based on this, we have identified the architectural style, which is microservice architecture. Okay. So architectural style has been identified. So what we do in the microservice architectural style, basically it is, there are certain principles within the microservice architecture, right? One of the principle is single responsibility principle. Have a component which takes care of a particular responsibility, correct? Okay. So I'm not talking about microservice architectural fundamentals here, right? But this is one of the principle we have, single responsibility. What does it mean is, have a component, that component is taking care of a particular role or a particular responsibility, right? So that's something they will say, or this is one of the important guidelines, right, within the microservice architecture, right? What also microservice does is it provides that modularity. You will break your functionality into small modules, right? So that you can maintain that module individually, as well as you can scale that module individually as well. Okay. How do you break your architecture into small modules? So that's where in microservice concepts, you have something called domain driven design, right? Or bounded contexts is something we call, right? Okay, so what does it mean is basically divide my architecture into small domains or small modules which can work independently. Okay, so what I have done based on the requirements, what I have done is I have broken down my requirement into small chunks or small domains. One domain is, one guy need to take care of user management, right? So we will have what new users will be coming and logging into, I mean, registering into Twitter, right? So we need to have one capability or one domain which takes care of user management. Okay, right? And we have a requirement, right? Users can follow others, right? If you go to a functional requirement, right? So based on the functional requirement, I came up with one more domain or one more capability called user follow management. Okay. So this guy takes care of, hey, which users follow which user and all that things, right? One more domain called tweet management, like creating a tweet, updating a tweet, deleting a tweet, all those things will be taken care by tweet management. Okay. We have one more requirement like a favorite, right? One tweet can be mapped as a favorite to a user and all that, right? For that purpose, I have created one more domain called tweet favorite, right? And the requirement is we need to have a timeline generation. I mean, we need to see on a timeline, we need to see what are the tweets your friends have been tweeted, right? That's a timeline generation, right? And also we had a search functionality. We can search for tweets and all those things, right? Media management, right? So there was a requirement saying that the tweet can be audio or a video as well, right? The media management. So based on the requirement, folks, if you are not talking, please be unmute. So there is some background. Yes. Okay. Right. So this is what we have done, right? So we have adopted this domain-driven design methodology and broken down our requirement into small modules so that each and every module can be managed independently. I'll stop here to see if there are any questions. Okay, fine. So let's assume, right? So our design principle or guidelines in your organization is something like this, right? Our decisions is like, hey, always go with APIs, preferably RESTful APIs. Okay, so this is your principle in your organization, or as an architect, you made that decision, right? So that why you have made this principle, so that you can monetize your API or you can generate revenue by sharing these APIs to a third party, something like that, right? So considering all this, maybe you have came up with this design saying that integration should happen via the APIs, right? As I'm going with the microservices, right? This is basically small APIs. So I decided that my integration between these modules or these components can happen via the APIs. Good. So far good, right? So these are my principles. Okay. So now I have a clear requirement, I have identified the non-functional aspects. I have identified the architectural style. I have identified all small components. Now it's time for to design. Okay, right? Typically, when you say design, what are the diagrams, what are the concepts we need to create, right? So typically the architecture is been represented in two standards. One is called 4+1 view. Okay, so draw your architectural diagrams in 4+1 view. What is that? One is use case view. Identify all the use cases. These are the use cases which we talked about at a high level, right? One use case is someone will register, right? Someone will mark a tweet as a favorite. All the use cases you need to identify, right? Maybe you can use UML use case diagram to identify and represent all the use cases, right? So in your final architectural document, you might need to have this use case diagram, right? Next is block diagram or a system integration diagram. Hey, what are the components I have? Okay, how these components are being uh, integrated together, right? So this is one block diagram. This is one of the in the 4+1. This one of the view is system integration diagram, or what are the components we have, how these components are being integrated together, right? Next is process or a sequence diagram. Tell me the flow. What is the flow chart? Give me that. Okay, someone is posting a tweet. What are the steps it is taking it? Maybe it will create a tweet ID. It will store the tweet in the database. It will, if the tweet is having some video or audio, it need to store in the media table, something like that, right? So there is a sequence of steps, right? So you need to have a process or a sequence flow. Okay, right? Next is class diagram, right? Are low level aspects, how the system is being designed, right? You need to have the class diagram as well. Okay, next is deployment diagram, how your application is being deployed, what are the modules, which server this module user management is being deployed, which server tweet management is deployed, how the replication is happening. All those things need to be represented here, right? So if someone looks at your architectural document, basically, if you have these sections or these diagrams, which is kind of talking about the complete scope of your project, right? So basically the first, right? This is nothing but requirement, functional requirement, right? That's the use case diagram is all about, right? If someone looks at, technical person looks at your requirement, your architectural document, they know what your application is doing, right? After that, how is these are the four diagrams which tell you how are you achieving the requirement. So the first one is all about what are you doing it. The next four is all about how are you kind of achieving it, right? So all these are UML diagrams or any other diagrams which you are comfortable with. Okay, right? So basically your architectural document or your design document, whatever you're creating, need to have what plus how. What are you achieving? How are you conveying the what aspect? By creating the use case diagrams, right? Okay, and how are you achieving it? How are you designing the system? You are conveying it via your system integration diagrams, sequence diagrams, class and deployment diagrams, right? So this is how generally the best practice to represent any architectural diagrams, right? So there is one more approach called C4 view. I kind of talked about in our last session, which is like four C's: component, class, forgot component, class, and yeah. So those are four C's will be there, right? So these people will kind of draw this component diagram, class diagram, use case kind of diagrams, all those things as well. This is one way to represent your architecture as well. Any questions so far? Okay, so if not, so let's start designing our application, right? Okay, so I am using Visio for creating my diagrams. Maybe I'll focus on the system integration diagram now. Okay, right. So my design principle is I'm going with the APIs. Okay, so I'll have one API or one individual module called user management. Okay, so I have something called user management. Okay, right. So this is what one module I have. Okay, this is the one module. Let's say this module is being deployed on a particular instance, right? And it supports various functionalities. What are the functionalities it supports? Read user, right? Write user, meaning register an user, right? And delete a user, right? And update a user. Basically, four APIs which takes care of CRUD operations: create, retrieve, update, and delete. So that is what the user management. Let's say this is running on particular JVM or a particular virtual machine with these operations, right? Okay, so this is what I had. Okay, and all this data is being stored in a user management table, user management DB. Okay, fine. So far good, right? So this is, let's say, a team A is kind of working on this user management. So in these are the list of system APIs or low level building blocks, right? And which is implemented using the RESTful web services, right? And it is talking to one of the database, right? This is how I am kind of designing it. Okay. So next is what I had is I had tweet management. Okay. So basically again, tweet, right? Tweet management, same thing. I'll have one more microservices. So each and every microservice have an individual component, right? So one more tweet management services which talk to its own DB, tweet management DB or tweet DB, something like this, right? Okay. So let's assume maybe how we can say is, let's say in the we have something called user table. It has ID, user ID, it has name, user address, and all those things. Let's assume, right, for simplicity. Okay. Now in the tweet DB, let's say you have something called tweet table. Okay, it has tweet ID, and who has tweeted this ID? User so and so, right? So that user details which is stored in this particular DB is being shared here. Example, let's say there is an example like something like this, right? There is a user. 1 second. Hope you're following. Stop me if I'm going fast, or stop me if you have any questions, right? Let's say this is a user table. Let's say user is 1, 2, 3, 4, and his name is, let's say, John, right? and he has registered on Twitter on let's say on so and so date, 1st of Jan 2022 or something like that. Okay, so this is the information I have about the user. Now I'll have a tweet table. Okay, what it will have, it's have a tweet ID. Let's say tweet ID is 1, right? Who has tweeted this? John. That is 1234. User John, right? He has tweeted this message, and we'll have the tweet message. Let's say hello world or something like that. Okay, this is what I had. So far good. Hope I'm making sense, right? So tweet table and a user table. This is what I had at a high level. Okay, right? And then we talked about media management as well. Correct? Media management. When I say media management, it's like, okay, tweet can have audio and video. Okay, so audio and video can need to be stored in a separate. I can't store it in a physical database, right? It is not a great idea, right? So typically we store it in some kind of an object store, like example, AWS S3 is one object store where we store the objects, right? So again, I have CRUD operations, read, write, delete, update. Okay? So for media management as well. So again, one more object store, right? Let's say this is some kind of a AWS S3 or some kind of a file, right, where the media is being stored, the audios and videos is being stored. Let's say I'm using some cloud, so this has been deployed on AWS object store. Okay, media management. Am I making sense so far? Okay, so now let's talk about media table as well, right? So in the media management, I'll have a media table. Okay, well, I'll have media ID. Let's say media ID is 10, right? And let's say it's a kind of what you call, it's an audio, right? The type is audio. Okay, and this has been related to which tweet 1. Okay, right? So basically tweet ID is acting as a foreign key in the media table. Okay, so this is how I have created this, my individual components or individual modules. So each and every guy is kind of taking care of its own responsibility, right? So this guy is taking care of tweet management, this guy is taking care of media management, this guy is taking care of user management, right? As we know, there are a lot of tweets happening, right? So let's assume as of now, this is how one JVM or one server for user management, one server for tweet, one server for media management. Now we are getting more tweets. In order to support that, I can scale that. How I can do? I can horizontally scale by adding one more tweet management instance, because there are a lot of tweets happening. So I've created one more JVM instance, right? So that I can support more load, right? Let's say there are now more people are accessing our application. So we need more capacity. So one more JVM instance or one more instance, right? Let's say more tweets, one more instance, right? So the user registration is not increasing it. Users are not same. Users are 1 billion only, right? But people are using our application a lot. There are a lot of tweets. People are posting the tweets like anything. Okay. In order to support that, I am just scaling the tweet management module, right? So this is the advantage, or this is the goodness of microservice architecture, right? You are scaling only the module which is required for you to support your business need, right? Now, tweets are also having a lot of images and videos. So in order to support that, you have added one more instance on the media management. Okay, so the user base is same. You're able to support the same users with one instance of user management, whereas you have created 4 instances of tweet management, so that that the tweet traffic can be shared between these 4 instances, right? Similarly, each and every tweet might have some media like audio or video, so that can be stored in the media management. Am I making sense? Right? So this is how we are achieving the scalability with the microservice architectural stack. I'll stop here to see if there are any questions. Okay, fine.
Now,
So similarly,
one question on how to convey the point of, let's say, the followers of user, that will also increase, right? Sometimes. So where
Sure,
will
sure.
that go? So the
Yeah. So again,
relationship in these two DBs and stuff like that.
sure. So what we have talked about, we talked about one more individual module for user follow management, right? So
Uh-huh.
what I'll be doing is I'll be creating one more guy called user follow management, one more JVM or one more instance, right? Where the user follow management service will be there, right? And that might be stored in a separate, altogether a separate database.
Oh, okay.
Okay,
Oh, yeah.
right? Okay, so how this user follow will be there? Okay, this is how the user follow table will look like. Okay, user follow. Okay, so what you will be having, you will be having the user ID and user ID. Okay, so these are the two columns you might have. Again, these are like a very high level, these concepts which I'm talking about, right? How it will be is something like this, right? User ID 1 is following 3 3. You got it, right? So what I mean here is one-to-many relationship is represented via this table, by this, right? So example, what I'm trying to say here is a user ID 1 who is like maybe user ID 1234, let's say, right? Whose user ID 1234, right? Whose name is John, right? He is following these users, user number 3, user number 4, user number 5, user number 6 and 7, right? So that's how I'm maintaining that user flow table, right? And this management, this one-to-many relationship, right, is being managed via this particular component or this particular module. Hope I'm making sense, right? Okay, so this way, if there are a lot of users follow management, or let's say we need to add new functionality here, let's say agility, right? Hey, we want to add some new functionality here, right? I don't need to modify the entire system. I just need to modify this guy, right? So that we can add new functionalities to the user follow management, right? So with the microservices, one more important characteristics which we support is agility. You can add new capabilities at a module level so that you don't need to impact the entire system. Okay, right? So like this, we have identified a lot of system APIs or the building blocks, right? Okay, like that you will be having for favorite, timeline, and search. You will also have individual modules, right? So in the interest of time, I'll just uh, assume like you have, okay, 1 second, I'll do it. Right. So these are the modules. This is the module for favorite management, tweet favorite management, right? This is a module for, uh, let's say, timeline, generating the timeline, okay? And this is the module for search, okay, fine. So each and every module is taking care of a single responsibility, right? Okay, so these are independent of others. If I need to do some certain search algorithm need to be modified, I just need to modify in this particular guy. I don't need to worry about others, right? If I need to change the ranking algorithm of the tweets in the timeline, I can just do it in the timeline itself, right? In this module only. Okay, so this is all the building blocks which we have identified, right? Using these building blocks, you can build the product, the actual product. Okay, that's what we'll be talking about. So this I will call it as 1 second, right? So this I will call it as system APIs or building blocks. These are like small bricks. Using these bricks, you can build a product. Okay, so these are my system APIs, which is running individually, all right, to take care of particular functionality. So far good, right? So now let's take a use case, right? Let's say there is a person called John who is registering for first time, right? And he is posting a tweet like "Hello world." That's what the use case is. Let's talk about that, like how it will happen. Okay. So what we will be having is we'll have a business layer or a process layer which takes care of the user management. Okay, so I have something called user management process. So let's say there is a person, there is some guy, let's say this is the John, right, who has logged into our application, right, and he is trying to register. So the control will come to my process layer. Okay, the user management process. What it will does, it will call my read API first. So step number one, it will call read API first. What is does it do? Does it do? Step number one, read API. What it does, it will check if John is already existing in the system or duplicate registration or not. That's the step number one. Okay, fine. So the process API is talking to my read API and checking if John is a new user or is a duplicate user. That's the step number one. Let's assume it is a new user. We could not find John in our database, right? What we'll be doing? Step number two, what we are creating? We are creating John in our system. Basically, we are calling the create API with John credentials. Okay, fine. After that, what we need to do? We need to call notification system. Step number three, call a notification API. Okay, saying that, or an email, send an email to John saying that your account has been created. Okay, what is that? Now we have identified one more component we need. What is that component? Notification system, right? So we need to create one more notification API, right, which can work independently to support notifications. Okay, so what we are doing, if you see here, we have implemented that process, that workflow in this process guide, right? It's just like, let's say, what is this process? Let's, from layman terms, think like this, right? You're building a bedroom. Okay, when you're building a bedroom, what you need to have? You need to have some space for your cot, some space for your what you call, for your wardrobes, and all that. Correct. So how do you do? In order to build your bedroom, you will first talk to your wardrobe design, right? So that's what we're doing it, right? So I'm building a bedroom, or I'm building a user registration process. First, I'm checking if I'm eligible to fix a wardrobe here or not, right? That's what the first check we are doing it. Second, we are creating a wardrobe by using some wood and all that, right? For which I'm using the wood specific services, right? After that, I'm kind of building on a bed or something like that, right? So the process is being managed in a separate module, right? So this is the user management process. Got it? So this, we call it as a process APIs. Okay, clear, right? So now let's say John has posted a tweet. Okay, tweet has been posted. Okay, I might have some information saying that John with hello world. This is what I have. Hello world. Now I need to store this tweet in our database, right? So John has tweeted, this is the username, and the tweet message is hello world. So the request came to my the process API. What I'll do, I'll check, I'll kind of get more information about the John. Okay, like based on the John, maybe I'll get more information about John, like what is the identifier for John, if he is John active in our system, is John authorized to send it tweets, is John following any other customers, all those things I need to know. So one more process to the user management to get more details about John. So I got all details about John. What is the John's ID? I got the John's ID as 1234. Oh, okay, 1234 is my ID. Okay, so what we have done by calling the user management, we got some more details about John. Now, after that, what we are doing, we are going to our tweet management API, right? Here, we are passing the information, user ID, which is 1234, has tweeted so-and-so message. What is that message? Hello world. Store it in your database. Okay, this is what we are doing it. Okay, so our tweet message will go here and it will store this message in this database, right? So this is one more process API. What the process API is doing, it is having a workflow. It is going to user management to validate the user, and then it is going to tweet management to store the tweet in the database. Okay, so this is one more workflow which we have built, right? So if you see here, basically we are building the product by leveraging the building blocks. By leveraging the small bricks, we are building the actual product. Okay. So these are, we call it as process APIs. So these are, we call it as process APIs, but basic nothing but it's having a process or a workflow in order to accomplish something. Am I making sense so far? Okay, fine, right? So on top of that, your business says that, hey, this functionality can be accessed via mobile, accessed via desktop, a web application, right? I mean, the web application, web portal, right? Or it can be accessed via the SMS. All those things are being provided by your business, right? If you look at mobile, you may not show a lot of information. Whereas on the web portal, you might show more information. Maybe in mobile, you will not show because of a small screen. And also mobile works on separate APIs for each and every channel as well. Okay, example, for mobile, you will have a mobile experience guide, experience API. Okay, from web, you have web experience API. What does it mean is this API mobile, it might return the request might have 2 parameters and response might have 10 parameters. Whereas in web experience API, the request might have 5 parameters and response might have 100 parameters. Okay, right? And you might have an SMS experience API, right? Where request might have 2 parameters and response also have 2 parameters. Okay, you got it, right? So what we're trying to do here is based on the channel or based on the client, right? We are trying to filter the response to improve the performance of the customer, right? So this we call it as experience API. Got it? Okay, fine. So if someone is accessing from the mobile, let's say John is accessing the Twitter from the mobile, how the flow will be? It will come to mobile experience and then it will go to the process API and then it will talk to the system APIs, right? So where we are ensuring John's experience is being managed via better by having only 10 fields in the response. If John is accessing via the web portal like www.twitter.com, right, then he might see more fields in the response, right? So this is an experience API. Okay, so this is how generally we try to create our modules or our system, right? So what are the components we have identified? By using the domain-driven design, we have identified many components, right? And our many small system blocks, right, which is running individually, right? And on top of that, we have built a process layer or a business layer. On top of that, we have built a UI layer or a view layer, which is nothing but an experience layer, right? So this is a kind of a high-level design about our Twitter system, right? Sometimes this layer mechanism, right? You are saying, right, 3 layers: experience layer, uh, process layer, and system layer, right? This is also called API-led connectivity. Okay, so this mechanism is called API-led connectivity, or there is a design pattern, architectural pattern called some BD, not BDD. I think there is a pattern for that as well. Okay, I'll stop here to see if there are any questions. Does it make sense? Is it okay? Are you able to follow on whatever we have discussed so far?
Yeah, but one question here: how do we represent the concept behind pushing tweets, pulling tweets for a particular? I mean, I'm asking from the API, the 4 views perspective. That how do I tell that okay, it is based on, let's say, whenever the user logs in,
Right.
Maybe I need to pull the tweets of his followers, right? For him to showcase in, let's say, some feed, okay, Twitter feed. So how do I represent that aspect, whether it's a push or pull architecture, what I'm trying to employ here, right?
So fine. Yeah. So now to satisfy our timeline generation requirement, correct? Okay. So you have one more process API, right? So let's say what this process API will do. Let's say John has logged in, right? Of course, it'll go to check. It'll check John is active or not, right? After that, it will go to our user follow management to see John is following which users, correct? Okay. After that, it will generate the timeline for these users. What are the for these followers? John is following ABC. What are the tweets we have for ABC, right? That's the tweet timeline. He's the guy who is responsible for that. Okay. To your question, whether we should use pull or push, or what is the mechanism, how we need to use it. Okay. I would say go for both, case by case, right? Let's say there is a user who is following only 5 users, very small users, right? So you can get all the tweets of your 5 followers easily, right? Within the synchronous communication. That is like a pull mode. Go to the your friends' tweets database, right? Get all the tweets and show it in the timeline, right? So that is what we can do it as well. Okay, simple use case. Let's say there is a user who is following 100 million friends, right? In that scenario, the pull mode will not work. I can't go to each and every 100 million customers feed or customers details and populate the timeline. In that case, that will not work. In that scenario, maybe you need to go with the pull mode, which means that, hey, for this customer, I have 100 million followers, asynchronously populate this feed and show it to the customers. When I say asynchronously, meaning you're trying to match or generate the timeline. Asynchronously, you're pushing some feeds to the customer timeline, right? So if you scroll to the page 2, maybe you will get next feeds. If you scroll to the page 5, maybe you will get next feeds. If you scroll to page 10, you might get next feeds, right? Because in this use case, the customer is having 100 million users which he is following up, right? So he need more data. So that can go via the uh, push mode, push asynchronously to the feed. Am I making sense? Does it answer my question? Your question, sorry.
Yeah, it answers. I'm just wondering, how do I represent that in this?
Yeah, sometimes that is at a low level, right? Again, so in
Yeah,
the
yeah,
we could not do it all, right?
yeah,
But that's how we will be doing it, right? So in the process API, you will be having multiple logics, push or pull based on certain strategy, right?
yeah,
You are
yeah,
means in the low level, what you're doing, you're adopting the strategy pattern for
yeah,
creating or structuring the tweets, right? So
yeah.
the tweet timeline generation is nothing but creating a timeline generation. You are going with a strategy pattern there in the low level.
Yeah,
Okay.
yeah, yeah. So, now one more question. So, how do I map this to, let's say, app server, dbtar, webtar, and where will be the LBs in this diagram, right? So that is a different view, or that can be mapped in the same view.
Ideally, yes, in the same view, right? So if you see here, right? So each and every system API have a requirement of scalability. It need to scale, correct? Okay. So
Yeah,
let's talk one more use, right? So there are lot of read calls than write, meaning registration will happen maybe in a given 1 hour. Maybe you'll have 10 registrations, right? But in a given 1 hour, there will be 1,000 users who will be logging to your system. Okay. What does it mean is read is more than write. Making sense, right? So in order to support read intensive systems, what we do is we use a pattern called CQRS, command, query, responsibility, segregation. What is command? Command is write, query is read, responsibility, segregation. I'm segregating separately. What does it mean is I'll have one JVM instance which takes care of read. I have another JVM instance which takes care of write calls, write, update, and delete. Okay, so this is nothing but using the single responsibility. What we're doing is we are breaking our modules into different responsibility. One responsibility takes care of read, one responsibility takes care of write. Okay, fine. So again, by leveraging the what you call the single responsibility principle is the same thing, right? So write is occurring against a separate database, user management database, and read is kind of occurring against a separate database, right? How the database will be in sync? We will be using some kind of a replication logic to replicate the data from A to B or B to A. Bidirectional replications will be implemented. Okay, fine. This is what generally we do for supporting the more read intensive calls. So now read is more. I am having lots of customers who is coming to our system to access the tweets. So a lot of read calls. So what I'll be doing, I'll be scaling this. I'll be having n number of instances, correct? N number of read instances. Okay, the n number of read instances will be there. So in order to, sorry, in order to load balance that, what I'll be having is I'll be having a load balancer at this level, at the system API level. Sorry. Okay, sorry. Yeah. So basically a load balancer will be deployed somewhere here. Okay. So this is the load balancer. So this load balancer will manage the traffic between the available instances. Making sense?
Yeah, thanks.
Okay, fine. So as we're talking about load balancers, maybe I'll talk about two concepts on the load balancers, right? Maybe that will give more clarity as well, right? So yeah. So in the load balancers, you need to take care of two aspects. So most of the robust load balancers have that, GTM and LTM. What is GTM? Global traffic managers. LTM, local traffic manager. So what does it mean is, let's take a Twitter only example, right? So you have Twitter running in India data center because they are global, right? You have Twitter running in India data center, let's say somewhere in Mumbai, right? And you have Twitter server running in somewhere in US, let's say somewhere in California, right? And you have Twitter running in somewhere in Europe, let's say somewhere in let's say London, right? And you also have Twitter running somewhere in Beijing to support China traffic. Okay, these are the various data centers which you have the Twitter being running, right? So this can be achieved via the cloud as well, meaning the cloud also support these kind of mechanisms. Okay, let's say you are logging to Twitter from, let's say, a city like Bangalore. From Bangalore, you're logging to Twitter. So as soon as someone logs in, okay, so this is the customer, this is the user, he logs in from Bangalore. So what it does is it will, as soon as the user logs in, it will come to our, what you call our global traffic manager, the load balancer, GTM, global traffic manager. As the name indicates, this is a traffic manager for the global. Okay, so as soon as the user comes here, right, so it will come to the global traffic manager. What the global traffic manager will do, hey, this guy is in India, right? What is my nearest data center? My nearest data center is India. So what this global traffic manager will do, it will manage or it will route the traffic to nearest data center, which is India, right? If India is down for some reason, what is the nearest data center for us? That is somewhere in Beijing, right? This is the nearest data center for us, right? So this is how the global traffic manager is kind of managing it. Okay, and then within India itself, you might have n number of servers, correct? So what does that is, what does it mean is, yeah, you have server A, server B, server C, server D, right? Something like this, right? You have server A, server B, server C, and server D. Server A, server B, server C, and server D. Because we are a population of 100 crores, right? So more than 100 crores. So like, yeah, so we need more servers to manage that capacity. So what we have now, we have local traffic manager. Okay, so what does that local traffic manager will do? So there is a person called Ashok, let's say, right? He has logged in from India, logged in from Bangalore. So the GTM, the global traffic manager, is routing that request to nearest data center, which is India. Now, within India, you will be having multiple servers. So your local traffic manager will determine, based on the server capacity, it will determine whether I should route it to C, D, or A, which is my available server. So in this case, let's say A is fully occupied, lot of it is processing a lot of customers. B is also fully occupied. D is also fully occupied. Maybe C has some capacity. So this guy, the local traffic manager, will route that request to C for processing. Okay, so this is how the load balancers will be configured.
Assuming ABCD will have all the app tier and web tier and DB
Correct,
tier.
correct. Let's say, correct, correct. Yeah. So which is nothing but user management only, right? In our case, right? User management is running in A, B, C, and D, right? And the data will be in sync. The data will be replicated against all the data centers asynchronously. Okay,
Yeah.
make sense? So this is how generally we kind of load balance our things, right? So this is all complicated or all complex as well. So you need to have right monitoring tools. So as an architect, you need to, after designing all this, one of the important non-functional aspect which we might have talked about earlier was, maybe I did not mention that, but we need to monitor and maintain, right? We are supporting a number of customers, right? The customer will say that, hey, I lost my tweet is not accessible, something like that, right? So we need to have some supporting monitoring as well, right? So you need to work with your stakeholders on how you are monitoring your server health. What are the monitoring tools you need to use? You need to make sure that you're monitoring your databases, right? There are various tools, various logging mechanisms are available in order to take care of that as well. Okay, so as an architect, you're responsible for kind of managing or configuring those monitoring tools for your system which you are designing it as well. So that's also your responsibility. Okay, I'll stop here to see if there are any questions. I know we are almost top of the hour, right? But any questions? Does it make sense? Right? Again, this is a very high level. In the interest of time, we could not talk in detail at stretch, right? But this is the high level how you can design your Twitter application by leveraging the microservice architectural style, right? And again, each and every architecture has its own trade-offs. Example, if you see here, the trade-off here is costly, right? You need to have a lot of hardware, a lot of support from various teams in order to build this system, right? But this is providing some additional capabilities or additional advantages like scalability and all, right? So there is no architecture which is super perfect, right? Every architecture has its own trade-off. So based on your uh, criteria, based on the cost, based on the timelines, you need to finalize the architecture. Okay, does it make sense?